Very welcome to this very first Creaternity impact moment. So if you who don't know what Creaternity is, it's a kind of research and education platform for connected circular economy here at Luleå University of Technology. So I'm Roland Larsson, a scientific leader for Creaternity. And if you want to learn more about Creaternity, please visit our homepage. You can see it in the background there. At this very first impact moment, we will have two exciting talks. Both are addressing the digitalization of a circular economy, you may say. And first we will listen to Ulf Bodin, and Ulf is a professor of cyber physical systems here at LTU. And he will give a presentation with the title Digitalization for the Circular Economy, Realizing our Strategies with Product Data. And after Ulf, Jaap van de Beek, he is a chair professor of signal processing here at LTU, and he will speak about 6G for sustainability. Are we all covered is the question also. But we will start with Ulf. So please, Ulf. Share.
Thank you, Roland. So I need to share my screen before we start. So let's do this. All right. So now you should see a presentation.
Yes, definitely.
And we're going to talk about digitalization for the circular economy. And I had to pick a fancy title. So now we are going to look into what our strategies means. Before doing that, as Roland said, I'm a professor in the Cyber Physical Systems group at Luleå University of Technology. That means that we in this group do research on different types of software artifacts in distributed systems, typically connected to some physical object. So in this case, it will be different products and subject to some circular use. So we do essentially distributed systems and software for the industry type of research. But before starting, I'm supposed to give a thanks to all the funders of this work. So connected to this presentation, these projects deserve to be mentioned. So we have funding from Green Transition North, which is supported by the European Commission. So it's a project together with Luleå University. Well, we are the Luleå University, but LTU Business, Skellefteå Science City, IUC, and also Boden, a municipality. Digitala stambanan, it's another project. It's funded by the Swedish Innovation Agency, Vinnova. And then we have Remanet and Prisma, both also funded by the European Union. So it's a set of different projects, which is important because that brings us in contact with various industries. So this presentation is largely based on the experience from these type of collaborations. So I want to talk about some regulations relevant to this, and especially the ESPR and the digital product passports. What happens beyond the regulations and how to use these things to improve actually the circular use of resources. And I'm a researcher, so it means that I like to see some challenges or work with some challenges. So I will give a little bit a flavor, let's say, about what it means to do some research in this area. And the idea is really that what we want to do is to create new business values from this. It's a regulation that drives it, but we aim at new business values. And we want to do this without actually imposing extensive cost to the industry, because that's a risk in doing these type of things. And that's generally a risk, I would say, with digitalization. So we need to know a little bit about what the digital product passport is. And what is it not? That's quite interesting, because it's not really a passport. A passport is something you bring when you travel, isn't it? So it's nothing like that. It's not something a product brings to pass borders, natural borders. It is rather a record of information that the product should be associated with throughout its life cycle. And this information should be accessible using, for example, things like a QR code. So using a QR code and a mobile phone, for example, you should be able to access different types of information relevant to the life cycle of the product. And all this is driven by the ESPR, and the DPPs are part of this. So that's a regulation now that the Commission, European Commission, has been working on for some time. So in a way, it started even before 2019, but that was the time when the European Green Deal was adopted. So that was a little bit of a starting point for all this. So it led to the adoption also of this ESPR proposal. It led to some priorities on different products. It led to an updated new eco-design ESPR regulation entering into force. So the eco-design, central to all this, is the idea of designing products, services, systems that actually take the environmental impacts into account throughout the life cycle. So there are some requirements to make this happen that the Commission has adopted, and the requirements are to improve durability, reusability, enhance things like maintenance, refurbishment. They are concerned with energy use, and make things resource efficient. It's always, for some projects in particular, the presence of certain substances that is related to inhibit circularity is important, and we want to increase recycled content. We want to ease the remanufacturing or recycling, carbon footprints, environmental footprints, generation of waste, and of course all this relates to sustainability. So these are requirements for this regulation that the regulation targets. And if we turn this now into something like information that should travel with, not travel across borders, but travel with the products. The type of information is something about the technical performance. It can be about the material and the origins. It can be repair activities. And again, recycling is important. And in general, environmental life cycle, environmental aspects or impacts. So this applies to a number of different products. So the regulation is supposed to cover, some people say all products. That's ambitious, right? But there is a plan, and the plan is to over some coming years, starting actually 2027, 26 actually, this will be mandated for different types of products. So early with materials like iron and steel, and moving on to aluminium, moving on to other energy-related products, eventually coming to things like textiles, ICT products. It's supposed to be sort of a gradual adoption of this digital product passport. And a little bit of a side note that this is actually done in addition to what has been discussed a lot also, and that's the battery passports. So it's pretty much the same thing, but it's a different regulation. So it's not really the same, but still it's very, very similar. So I'm not going to talk so much about batteries today, but whatever said here applies to some large extent also to battery passports. So the thing is now that some specific information that will be identified or is being identified by the Commission in discussion with different stakeholders and companies and the industry, it will be some decisions taken on precisely what information should be captured for the different products. And it depends on what actions should be supported, of course. So there are some quite ambitious ideas on how this should be used. And one question, I like questions since I'm a researcher. The question is, will this mandate it, because it will be supported by regulation and connected to standardization? Will that be enough to actually make business values of this? And can it be done without extensive cost? So these are some key questions. And to try to answer this, we can look a little bit more into this fancy word, the R strategies. And essentially, it's a way to explain what different types of actions or activities are relevant for circularity. And this is a little bit of a simplified view, but I think it's quite nice because it comes in three parts, three circles. And the first one, the pink one, is actually to reduce the consumption of resources. So it means to rethink or reduce by design the use of resources. Next comes the extension of the lifetime of the product, which is in the light green. And we can do this by repurposing. We can use this by remanufacturing or repairing or find different ways of have the project staying in use. And finally, eventually, we need to either sort of accept that this will become eventually waste, or we can recycle, especially some materials. So these are the different sort of activities that should be supported and that around which some values can be created. If you have customers that are willing to pay for a better circularity or a better sustainability, there is probably, or we more or less know already, that there are some business values in this. So implementing these R strategies requires some data, and that connects to the digital product passports. And the problem is that, or the challenge, let's say, is that quite likely you need some additional data, but what will be mandated by the DPPs in Europe. Because we need to support this repair maintenance. We make decisions for this. It needs data. For reuse and resale, we use records for this. So that data need to be available on the condition of things, warranty, certification information, and more. For the refurbishment and remanufacturing, we need diagnostic logs, failures, some instructions for how to disassemble things for refurbishment. So knowledge is needed for this, and we need data for that too. Recycling material recovery, we need some information on composition of things, what coating, what additives has been used. And the environmental optimization impact. We need to know things like what's the energy use, what's the emissions, and we need both primary and secondary LCA data for this. So primary is directly connected to the product, and secondary, that's typically quite aggregated data for life cycle analysis. So that goes beyond, most likely, because it looks like the DPP mandated data will be sort of a minimum set upon which you can add more data for added value. So the challenge now, without extensive cost to associated with collecting and sharing data, the problem is that it involves multiple interdependent activities that typically pose challenges for the industry to collect that data and share that data for all these purposes to the right in the picture. And if you look into the data collection and the data integration needed for this, what we must do is to capture trustworthy, fine-grained life cycle events, all these things to support these different types of activities. We also need to create some model of federated data sharing, because the Commission already say that the DPP architecture is supposed to be decentralized. So we need to understand what that means, and we need to use that to find solutions for how this federated data sharing should happen. And finally, the lifecycle management of the data, the DPP data. We must make sure that it remains usable and accessible through the product lifecycle. So to give some flavor on what is actually the type of research is of interest in this, I'm just going to use the first group of type of challenges as an example. And if you look into the data integration and the scalability connected to this, most approaches for data integration, they aim at providing a unified view of the data to make it useful. The problem is that it quickly becomes quite resource and time intensive because the number of sources and the data elements increases, and usually this data is scattered around in the different industries. So it doesn't exist in a single place. It has different origins, it is stored in different places, and it's time consuming to collect this data and assess this data and make it available for this purpose. So the approach can be to use some semantic technology like ontologies, knowledge graphs, to support this data integration and to minimize the resource overhead, which usually means to automate this processing to avoid the always manual work involved in this and minimize that. If you look into the product data assembly, the traditional data integration typically designed for query-based access, while this DPP type of information is about assembling product data from many multiple heterogeneous sources. So the question becomes, to what extent can the process of this be automated across the heterogeneous data sources and system? Again, automation, that is. And how can the standardized vocabularies and ontologies that already is out there be used for this automation? So that was all things I wanted to cover. So in the presentation, it's also a number of references used. So in case anyone wants to follow up and dig a little bit deeper into things, hopefully these are useful. And that's it.
Okay, thank you very much, Ulf. So I think we have some time for questions also. So please feel free to ask questions. You can let me know later if you don't want your question to be recorded, because we are recording this event. But please feel free to ask Ulf questions now. So.
I can admit that I've stolen a few slides from one person in the audience, Eric Chiquito. So there are more experts than me in this group, for sure. So thanks, Eric.
But that's
no problem.
That's research. 99% stealing, and then you add 1%. That's a typical science. Now, what I mean, you covered that in when you talked about the challenges, but it becomes pretty complex if you are a producer of a product in the future, and then you need to start adding this information as well. It becomes difficult for some types of producers, I guess, especially the smaller companies, but maybe they will not be forced to do that very soon, but soon they will need to do that. I guess it's worth. I mean, is this a way to go to create sustainable development? I mean, it makes everything more complex. So I guess you get. Can you put it that you get so much more value also? The cost for it will be maybe high, but then you get additional value. Is that a way to sell this? Apart from the law, the laws forcing you to have a passport.
That's hard to know, of course, but I would say that when talking to industry and looking back in the recent, I would say 10, 15, maybe 20 years, companies has tried to share data on the products and track different things, and hasn't really been able to. I believe it has been what hinders them is probably that they haven't found a good enough business case for this. So what's interesting now that they all of a sudden they don't have a choice, and if you don't have a choice, you must do something. You need to start associate data with your and actually individual products. Then the situation is different. Then the business case just need to add value. It doesn't need to cover this sort of infrastructure for data sharing as much. So I think at least it lowers the bar. So that's one observation at least. But it will be difficult for SMEs, as you say, because they don't usually have this the capacity, the internal people to do this. And it's already a number, I would say, a great number of other software companies that want to solve the problem for also SMEs, but they also want to charge a lot of money for it.
Yeah. Comes with a cost, of course.
See. I think Lars has a question.
Lars has a question.
Yeah, is it any branch or sector that are doing this, that have a supply chain that working?
Supply chain that is working. You mean for the DPPs or for this?
Yeah,
type of
for
data?
the DPPs.
I don't think anyone has that for product individuals, but companies usually have that for sort of a type of product.
Which kind of products?
Well, you have that for many products. You can use the environmental declarations, for example, for products today that comes with everything, like a dishwasher, any electronics that you buy for your home is labeled, right? That's the environmental declaration. But they have this information for a product type, not for a product individual. So, and I think that's an example of that. Pretty much of the data now being needed for the DPPs already exist, but not necessarily on the product individual or product item level or product batch level. So that's an issue. And when starting to look for this data, you need to revisit. If you look into a large industry, for example, a typical case is that the data exists already in different databases. But the problem becomes that it was collected for different purposes. The collection started, the logging into different databases started many years ago. So it's even so that we have stumbled upon situations where companies have the data, but they don't know from where it comes in the production. They don't know the accuracy or the quality of the data, and it's just there in the database. So it's a lot of lost knowledge and things that has happened and investigations needed. So that's part of the cost also in this.
Yeah. Okay. Yes. So please feel free to contact Ulf if you want to discuss further with him. And you find him on LTU's homepage. I'm pretty sure about that. So then we will thank you very much, Ulf, and we will move on to the next speaker then, and that's Jaap van de Wijk, and he will speak about maybe the infrastructure for bringing those passports with the products, even if connect the products maybe to the web. So please, Jaap.
Yes, exactly. So let me see if I can share my slides. There you go.
Yeah.
I think you should see them now.
Definitely.
Yeah, so my name is Jaap van de Wijk. I'm the chair with signal processing here at LTU. And I will talk about 6G and how it relates to the topics we discuss in Creaternity and how it can help the circular economy and sustainability. And So I will talk a little bit broader than the particular project that we do in this within Creaternity. But when we talk about 6G now that is coming up here, a lot of people may think about these phones, and the phone on the right is what we typically use today, and we have them of the fifth generation now in our pockets. And some of you may recognize the phone on the left. This was roughly when the signal processing group was founded here at LTU in the end of the 80s. So this is the first generation to the fifth generation, and now it's time for the sixth generation. So I want to talk a little bit about the possibilities and how this next generation is thought to enable much of the work we do within Creaternity. So, obviously the phone on the right-hand side can do so much more in terms of functionality and in speed. It's amazing how much we have accomplished in 40 years. But in one way, the phone on the left is better. We lost something, and it's basically the coverage. The phone on the left has many people will nostalgically think about that about the phone on the left in the way that you hardly had dropped calls or lost connections. It had a huge output power and obviously needed a huge battery as well. But so the coverage will come back in this talk a little bit about how that coverage can be a problem. So 6G then, so it started basically the standardization of 6G started seriously 2 weeks ago with a meeting in India, and a huge meeting as usual, 1,500 delegates, 22 meeting rooms the whole week. People started to create the 6G standard, and the idea is that within 3 years from now the standard will be ready by early 29, and products will then hopefully being developed and appear on the market in the early 30s. So that's the roadmap, if you want. And so then the obvious question is, okay, sixth generation 6G, how is it different from 5G? What can it do in terms of functionality? And what in our particular more narrow look on it, what can it do? What can it mean for the circular economy? So 6G will be one standard that's not only about connectivity or communication anymore. So it still will be about communication, but it's not only about higher speeds, higher capacity, higher bit rates, etc. There will be at least two fundamental aspects that will be added in the coming years in the standard, and that's computation and it's sensing. And so computation is basically the idea that the whole 6G network will be natively prepared for AI and high computation applications, so that whatever you want to do on your phone, you can quickly offload that to the nearest base station and have things being computed and with massive computation power in the network, and the communication in the network will be prepared for that kind of traffic, if you want. And then there is sensing. So the idea is also that if you have a network for communication in place anyway, if you have all the base stations everywhere, why not also use it for other purposes and to infer perhaps things about the physical world in the neighborhood of those base stations that can create value. And that is particularly what our group is working on right now, on the sensing part. What can we infer knowledge about the world? Positioning, I will come back to that extensively. Position, localization of devices, rather than simply communicate with them. And that is one of the things that potentially can help also the circular economy, is knowledge of localizations and knowledge of positioning. But I come to that. So in a broader sense, the combination of these computations and sensing and communications will be in many ways help and to accelerate this circular thinking and the sustainability. I listed here 4 categories here. On the left-hand side, we have the massive integration of very small IoT devices that are directly connected to the internet. So we don't think of the big phones that we have in our pockets only, but any small label or tag may be an IoT device which has direct connection with the 6G connection with the internet. So that will help for perhaps traceability and tracking and so on. In the second category, we can have, this is mostly the computation, right? We have the AI that can quickly compute and quickly help us with decision making, logistics, smart logistics. We can potentially in real time make very complex decisions with the help of that computation power. Well, we have energy. The third one is the passports that we talk about, that Ulf talked about. They can be real-time connected, right? So we can quickly access those. We can quickly update them. We can expand them and extend them. And the connectivity adds a new, let's say, possibilities and a dimension to these passports as well. And then we have new business models where, and I won't go into that too much now. So I will mostly talk about the left part, this real-time tracking of devices and of small devices, of products and so on. So positioning services, localization services. So if we can, with the network, with the 6G network, very precisely find out where things are, that can help a lot, right? We can localize resources, products, waste. We can localize them across time over a life cycle. We may combine the position suddenly with identity in the passports. And when on a larger scale, we may do also help with smart logistics. When we know where things are, where products are, and on a real-time basis with geotagging, well, we can do a lot probably in terms of dealing with logistics in general. So precise localization and positioning is probably an important part of this. So there's basically 2 regimes that we are talking or looking at in our group. That are very fundamentally different in terms of the localization, the challenges, but also the precision and other ways that we can track and follow things. The first is the left side. It's basically indoor, small scale. We're thinking about warehouses, for instance, where products are tagged and where we want to find where they are with a high precision indoors. That is a very difficult problem. To find, to know, to predict where they are, to track them. In factories, we may also want to also in a similar indoor regimes, we want to track things, stuff. And this is difficult because when we think about today's localization, we mostly think about GPS, which is typically not we cannot use it indoors. And so the requirement having like centimeter precision of localization of finding things indoors, that is really a challenging problem. And then we have on the right hand side the other regime. It's a large scale regime. If we want to track stuff that is moving around in containers over the world in product streams, that we have the problem with coverage. Also with radio coverage, 6G coverage in a whole different dimension. The fact is, well, in remote areas, we don't have coverage at all. There was no 3G, there was no 4G, there is no 5G. And will there be 6G at all there? Is that feasible? And also we have the thing there where we can rely on GPS, and that is what happens when GPS fails. I will come to that. So there is a tension here, and I already have like touched on that, between the accuracy of positioning, millimeter precision, centimeter precision, or higher, and the coverage, the 6G, the coverage, whether or not we have good signal strength where we are, right? And in the local regime, in the factories, the warehouses, there that is a problem. We may have obstacles, we may have wall penetration, and we don't have so much output power from our base stations. So the question is, can we really look everywhere, or will signal strength be too small for accurate localization and positioning? And also in the large regime that we have, I already said, I mentioned that in the previous image, we have these, there is sparse infrastructure. We may not even have coverage in the first place. So how do we look at that? So in our group, we look at two kinds of technologies, new technologies, one in each regime, if you want. And I have one or two slides on each of them. One is on the left side, the indoor regime. We look on an emerging technology of intelligent surfaces. I'll come back to that. And in a large scale regime, we look at positioning from satellites. And then notably, not GPS satellites, but low orbit satellites. So yeah, these are the two students, Simon and Fayal, who are working with these positioning problems in my group. And in the middle, you see a picture of such a, for the small scale regime, the indoor regime, these intelligent surfaces. Right? So these surfaces are basically, they're not antennas, they're just passive surfaces that reflect radio waves. Right? They are not emitting anything. They're not base stations. They're not relays. They don't have any. They don't need much power. They don't emit anything. The only thing they do is they reflect. They're like mirrors, right? But they're smart mirrors. They're smart mirrors in the sense that they can direct the waves in directions that we choose as engineers, as deploying these. And this helps us to provide coverage around corners, around in factories, right? In places where you, without these surfaces, would not have proper signal strength and wouldn't be able to do localization. We can use these, hopefully, use these surfaces, mount them on the wall, and help them provide coverage and increase the positioning accuracy. So both Simon and Fayal have been looking at these intelligent surfaces and how they can help positioning in factories, in warehouses. And yeah, so this is how this is in a corridor system or in a crossroad system in an urban environment, how coverage can be improved. Like the left side is more like the image. We have one base station, this the dark dot. And we have 4 streets, and we have some coverage, and most of the coverage is in the black area. That's where we illuminate or highlight, can find the position. But then the idea is that what if we add some of these surfaces on the houses, wall mounted? Then suddenly there is also coverage further up in the corridors or in the streets. And we create actually coverage, a better coverage where there was no coverage before. And this can be used to also improve the positioning and to tracking and to keep track of these all your devices and your stuff when they further away. So that is what Simon has been looking at. He has been looking at what if we have some. This is the map. This is a map of a bigger area, an indoor warehouse, if you want. And what if we have, instead of three base stations in this on the wall mounted here, what if we have only one base station but instead add one of these intelligent surfaces? Can we still provide positioning in sufficient accuracy? And the answer is yeah, we may. So in other words, can we reduce the density of our base station, and with these simple or cheaper surface devices still provide a good positioning, right? So without going into detail here, the answer is yes. These surfaces can actually compete with more expensive base station devices and maintain a coverage of less than a meter. We are in the 30 centimeter accuracy in this figure, for instance. Yeah, so then that's basically the indoor regime so far where we are working, and then moving to the other regime, the large scale regime. So this is another fundamental thing that will be added in 6G, and that is we all know the Starlink constellation that now is up and running, and with thousands of low orbit satellites. So the idea with Starlink is obviously not a standard. It's a proprietary system. You need proprietary terminals. You need you need dedicated subscriptions with Starlink or their immediate partners. The idea with 6G is also to incorporate in the standard a specification for standardized satellite constellations, right? So the idea is that after the standard has been set in 2029, new operators, international global operators, may start to deploy their own network in space, in low orbit, but fully integrated then with the terrestrial networks, the 6G terrestrial networks. And the idea is that which has huge advantages, obviously, because suddenly all the 6G compliant phones and equipment, regardless from what manufacturer, will be able to connect to this network. And so that is a part of 6G that has gained a lot of momentum now in the standard, and that is also where our group is now looking at. In particular, we're looking at the positioning from these low orbit satellites. So what we are used to so far is the positioning from GPS, right? Much higher up in the sky, but very accurate positioning. But many of us now are worried that we may not have access everywhere, always, to a good GPS signal. Either GPS may be switched off or it may be jammed. So the idea is that once you have these 6G constellations in low orbit anyway, for communication purposes, then why not also make those constellations provide the position and the location of a phone, much similar to what GPS does now. And this is a hot topic also for out of the standpoint of resilience, right? Obviously. So can we have and this is a new problem because these satellites move much lower. So on one hand, they're much closer by than GPS satellites, but they move much faster. So there is much more other problems related to Doppler, etc., etc. And it's we have just started this work, but we'll see to what extent we can match GPS accuracy, and we probably can't. But even if we can't, any other less accuracy may also be sufficient and add value to the system. So yeah, so the last part is much related to this new research center for 6G satellite communications, which our group is a part of, and LTU together with KTH, and this will go on for the coming 6 years, well, basically work parallel with the standardization with large companies on 6G satellite communications. Okay, so the takeaway of this talk is basically 6G positioning will be, or hopefully we envisage that to be a key enabler for the circular economy. It will be a large contributor to business models and new open up for new possibilities. Good coverage of 6G, both indoor and outdoor, is critical. So what we need somehow to provide coverage, and then based on that coverage, see what kind of accuracy in terms of positioning we can get. Yeah, and within Creaternity, we built this kind of expertise on 6G positioning in both scenarios. Okay, I stop here. Thank you very much.
Thank you, Jaap. Very, very interesting. Thank you. So we have definitely time for some questions. Someone is volunteering. But is this will this make now IoT? It will revolutionize the IoT. I mean, has it taken off yet, or will this make it to take off in a bigger extent?
Yeah, that's a good point. So from many points, much of the 5G functionality has not taken off really, right? There's more and more the idea that 5G is somehow not living up to the promises it makes and it made when it was standardized. And but yes, the hope is, or the vision is still that for 6G these kind of localization and accuracy will be provided. Yes.
Yeah. Micke.
Yes, just to follow up on that, the latest number of New Technique, there was an interesting article about 5G and so on. Since a little bit about complaints there, since somebody talked about it's not real 5G out there yet, but it's really the foundation to get the real 5G, standalone 5G working before we can actually, that is needed to pave the ground for 6G. So it was interesting to read that article, to see that we are at LTU here. We're on the topics in several areas there. Just a comment. But what I'm really would like to ask is, when do we see or use 6G as a private person, do you think?
So the projection is like early 30s, perhaps 30, 32, 31, 32.
Fair enough.
And what do you think the first applications for us?
Yeah. So that's also a good point. They made, somehow it has been admitted by many companies that they made a mistake with 5G to have some kind of a transition system between 4G and 5G. It's called 5G non-standalone, and a lot of operators started with that in the networks, and it had only like limited performance in the beginning, but they didn't move on to the full 5G implementation, and that was somehow a mistake by the vendors. But because that is, a lot of operators are somehow now they have not used even the full potential in 5G, and they will not do that in 6G. So there has already now been the idea, we will not make that mistake in 6G. We will make a system that right from the start is somehow not backwards compatible, right? We won't do a soft. So which means that we will probably, hopefully, from the beginning of 6G immediately get these kind of at least, well, simple somehow positioning and sensing functionalities. And there won't be a system that is just half 6G or so.
No. Definitely this opens up for new business ideas. So it's just start thinking about how to make use of knowing where, also in sustainability or circularity, knowing where all your products or components are all the time, and how their condition are at the moment. That opens up a lot of possibilities, definitely. So let's
we just have to hope that the focus on the first applications will be some kind of elderly care, because you and I, Roland, have retired by that.
Yeah, yeah. Now the chip we have now in our necks, it can be useful there. So it's 6G. We are first test persons there. So no, but if we don't have any more questions to Jaap or to Ulf, I would thank both Ulf and Jaap for very interesting, nice presentations. And so this was the first test of the Creaternity impact moments, and I think those moments made a lot of impact. So we have recorded it. So if you want to watch it again, you can do it. And if you watch it for the first time, this is what you get also in the next impact moment. So thank you very much, and see you soon. Bye bye.
Thank you.
Thank you.
Bye-bye.
Bye.
Very
Bye.
good presentations.
Yeah, very good.
Thanks. Bye bye.
Thank you. Bye.